Hey everyone, in this video we're going to learn how to solve linear quadratic systems of equations algebraically. So in the last video we solved these systems of equations graphically and we saw there was 3 potential outcomes. There could be 2 points of intersection, 1 point of intersection, or no points of intersection. So it's important to keep those 3 scenarios in mind as we're solving these systems algebraically. Our first example, y equals x squared plus 3x minus 9, and y equals 4x plus 3. So based on how the equations are given to us, substitution method is the easiest because we can substitute 4x plus 3 in for y. So we have 4x plus 3 equals x squared plus 3x minus 9. So we can move everything to one side so that the equation's equal to 0. So subtracting 4x would give us minus x, subtracting 3 gives us negative 12. I'm going to rewrite that as x squared minus x minus 12 equals 0. So it looks more familiar. Now we can try to factor this. So the factors would be x minus 4 and x plus 3. So that means either x minus 4 equals 0 or x plus 3 equals 0. And we have either x equals 4 or x equals negative 3. Now for each of these x values, we have to find the corresponding y value because we're looking for points of intersection. A point is an x and a y value. Well, we can plug x into either of the 2 equations, but plugging into the linear function is going to be significantly easier, in my opinion. So we're going to take x equals 4, plug that in, so we have y equals 4 times 4 plus 3. So y equals 16 plus 3, which is 19. And then here we have y equals 4 times negative 3 plus 3. So y equals negative 12 plus 3, so that's negative 9. So our 2 points of intersection are 4, 19 and negative 3, negative 9. So there we have our first system of linear and quadratic functions solved algebraically. On to the next, which is y equals x squared plus 2x minus 1 and y equals 6x minus 5. Again, set up for substitution. This time let's substitute x squared plus 2x minus 1 into y in the second equation. So that gives us x squared plus 2x minus 1 equals 6x minus 5. We have a quadratic equation, so it needs to be equal to 0 in order to be solved. So x squared will subtract 6x from both sides, so minus 4x. And we'll add 5 to both sides, so plus 4 equals 0. We can factor. The factors are x minus 2 times x minus 2 equals 0. So either x minus 2 equals 0 or x minus 2 equals 0. So either x equals 2 or x equals 2. Well, those are the same x values, so that means that there's only 1 point of intersection. So we have to find only one y value. So y equals 6x minus 5. So y equals 6 times 2 minus 5. So y equals 12 minus 5, which is 7. So our point of intersection, the solution to this system of equations, is 2, 7. Perfect. Next up, we have y equals x squared plus x plus 5 and y equals 1/2 x minus 1. So again, let's substitute x squared plus x plus 5 into y equals in the second equation. I think that was a little bit easier. So we have x squared plus x plus 5 equals 1/2 x minus 1. Well, I really would rather not work with a fraction in this equation. So let's multiply both sides of the equation by 2. So we'll distribute 2 into the trinomial. So we have 2x squared plus 2x plus 10. And we'll distribute the 2 into the binomial, which would give us x minus 2. Now we have a quadratic equation, so it needs to be equal to 0. So we have 2x squared. Subtracting x on both sides gives us plus x. Adding 2 on both sides gives us plus 12 equals 0. Now we need to factor here, so we have 2x and x. That leading coefficient is prime. So we need to cycle through the factors of 12 to figure out, after we distribute, which would give us positive 1 in the middle. So, I'm not sure if that's going to work. So let's go back to the drawing board. Maybe it's not factorable. And if that's the case, well, let's check the discriminant. So the discriminant here is going to be b squared minus 4ac. So we have 1 squared minus 4 times 2 times 12. So we have 1 minus 8 times 12 is 96, which is negative 95. And when our discriminant was negative, or not a perfect square for that matter, that told us that the quadratic was not factorable. And if this isn't factorable, or we can't even use the quadratic formula because it's negative, that means that there's going to be no solution. Okay, so there's no solution to this equation, which means that there's no solution to our system of equations. Okay, so let's run that through again. We found the discriminant, we got a negative number. At first, we were just checking to see if this was factorable or not. If it wasn't factorable, we could have used the quadratic formula to solve. But when we found the discriminant to be a negative value, in our quadratic formula, we'd be trying to take the square root of this negative value, which would not give us a real solution. So for that reason, it being negative, the discriminant, we know that this quadratic equation has no solution, so therefore this system of equations has no solution. Okay? If you had tried to do it with the grouping method, you would have done 2 times 12, which is 24, and trying to think of a factor pair of 24 that adds to positive 1 would have left us stumped and confused. So either way, you would wind up with the discriminant, hopefully. Okay, so we've seen an example that had 2 points of intersection. We saw an example that had 1 point of intersection. And now we've seen an example where there's no solution, or no points of intersection. Next up, y equals 2x squared plus 4x minus 10, and 3x plus y equals 5. So let's substitute 2x squared plus 4x minus 10 in for y in the second equation. So that's 3x plus 2x squared plus 4x minus 10 equals 5. So we have 3x plus 2x squared plus 4x minus 10 equals 5. We can combine like terms on the left side, so 2x squared plus 7x minus 10 equals 5. We have a quadratic equation, so we need that equal to 0. We can subtract 5 on both sides, so minus 15 equals 0. So we can factor this. 2 is a prime coefficient, so I'll go with the guess and check method, but by all means, if you're more comfortable with the grouping method, multiply 2 times negative 15 and go from there. So we need to go through the factors of negative 15 so that if we distribute out our factors, we get 7x in the middle. So let's see, if this is plus 5 and that's minus 3, would that do it? So I'd have 10x minus 3x, which is 7x. So either 2x minus 3 equals 0, or x plus 5 equals 0. So x equals 3 over 2, or x equals negative 5. Now just quickly on the side showing what you would get with the grouping method, because it's great review. We'd have negative 30, so a factor pair would be 10 and negative 3. So you'd have 2x squared plus 10x minus 3x minus 15 equals 0. And from there you would proceed to group the first two and the last two terms together and solve. And you would wind up with these two factors in the end. Okay, so we have our x values, we need our y values. So we have to solve. So 3x plus y equals 5. So 3, no, don't want x, I know what x is. 3 times 3 over 2 plus y equals 5. So that's 9 over 2 plus y equals, well, let's just get a common denominator so we're set up to subtract. So that's going to be 10 over 2, right? 5 over 1, multiply by 2 over 2 in the numerator and the denominator. So we can subtract 9 over 2 on both sides, so y is equal to 1/2. And then x equals negative 5. So 3 times negative 5 plus y equals 5. So negative 15 plus y equals 5. Add 15 to both sides of the equation, y equals 20. So our points of intersection are 3/2, comma 1/2, and negative 5, comma 20. This is a perfect example that if we had tried to solve this graphically, that 3/2, 1/2 point would not have shown up perfectly, unless we scaled our axes, but we wouldn't have thought to do that in the beginning. So the algebraic solution would be the way to get that point, or to go back and redo your whole graph with a better scale factor. Next up, y equals x squared minus 5x plus 9, and y equals 8 minus x. So we'll substitute x squared minus 5x plus 9 in for y. So we have x squared minus 5x plus 9 equals 8 minus x by substitution. We have a quadratic equation, need that equal to 0. So we'll add x to both sides, so that will make it minus 4x. Subtract 8 from both sides, that will make it plus 1. Well, just looking at this quadratic, it's not going to be factorable. So in order to solve this, we have to use the quadratic formula. So a is 1, b is negative 4, c is 1, so our discriminant is b squared minus 4ac, so b squared minus 4ac, so that's 16 minus 4, which is 12. So that does confirm that we can't factor this, but we can definitely solve it. It's not a negative discriminant, so we can use our quadratic formula. So x equals negative b plus or minus the square root of the discriminant all over 2a. So the square root of 12 can be simplified to the square root of 4 times the square root of 3, which is 2 times the square root of 3. So simplifying, negative 4 is positive 4, plus or minus 2 times the square root of 3 all over 2. In the numerator, we can factor out a 2. 2 plus or minus the square root of 3 over 2. The 2 in the numerator and the denominator simplify. And we have x equals 2 plus or minus the square root of 3. Okay, so that means we have either x equals 2 plus the square root of 3 or x equals 2 minus the square root of 3. Now remember, we still have to find those y values. And y equals 8 minus x. So here y equals 8 minus, in parentheses, 2 plus the square root of 3. So y equals 8 minus 2 minus the square root of 3. So y equals 6 minus the square root of 3. And then for our other x value, we have y equals 8 minus, in parentheses, 2 minus the square root of 3. So y equals 8 minus 2 plus the square root of 3, which is y equals 6 plus the square root of 3. So our 2 points of intersection look a little bit more complex here. So that's 2 plus the square root of 3, comma 6 minus the square root of 3, and 2 minus the square root of 3, comma 6 plus the square root of 3. So there are our 2 points of intersection, and this is an example that definitely would be impossible to solve graphically. The only way we're coming up with these 2 points of intersection is algebraically, which is why we have to go over both methods, right? Algebraically will always work. Graphically, if the points are nice, we'll be able to find them. And it's nice to also visualize what this system of equations look like. Okay. Our last example, determine the number of points of intersection between y equals 2x squared plus 15x minus 6 and y equals negative 2x plus 3 by using the discriminant of the quadratic created in solving. Okay, so let's take a step back for a second. They're not asking for the actual points of intersection. They just want to know the number of points. How many? And then it says using the discriminant of the quadratic created in solving. Okay, so they don't want the discriminant of this quadratic. They want it when I'm solving. So let's start solving and see if we get to the point where this makes sense. So we'll solve by substitution. So we'll substitute 2x squared plus 15x minus 6 in for y. So we have 2x squared plus 15x minus 6 equals negative 2x plus 3. So we have a quadratic equation we're trying to solve, so we'll set it equal to 0. So we have 2x squared, we'll add 2x on both sides, so plus 17x, and subtract 3 on both sides, so minus 9 equals 0. Well, this is the quadratic that I'm trying to solve in order to come up with the solutions to the system of equations, so the problem wants me to find the discriminant of this quadratic. Okay, so the discriminant is b squared, so 17 squared, minus 4 times a times c. So let's see, let's use the calculator here. 17 squared, 289. So we have 289, and then plus 4 times 2 is 8, times 9 is 72. So we can go back to the calculator here. 289 plus 72, that's 361. Okay, so the discriminant is positive. So when we had a positive discriminant, we had unequal solutions, which means there's 2 of them. Well, if there's 2 solutions in the quadratic formula, that means we're going to have 2 points of intersection. Okay, so we have 2 points of intersection. So essentially what this question is asking us to do is go back to that nature of the roots. And it's tying in the nature of the roots to solving a system, a linear quadratic system of equations algebraically. So we start solving, we get a quadratic that we would find the discriminant of in order to solve. And here they don't actually want the solutions, they just want to know how many solutions are we going to have. So the fact that we have a positive discriminant, right, back to the nature of roots, we would describe the roots of this quadratic, 2x squared plus 17x minus 9, not a quadratic we're graphing. We would describe the roots as real, rational, unequal. Unequal is the important part because that means there's 2 solutions to this equation, which means we'll have 2 points of intersection. Okay, so just to quickly recap what we did in this video, we solved linear quadratic systems of equations algebraically, whether that was by factoring or with the quadratic formula. And then we saw 3 different cases. Systems where there was 2 points of intersection, systems where there was 1 point of intersection, and systems where there were no point of intersection. or no solution. Okay, so go practice your algebraic skills of solving and also working on these linear quadratic systems of equations. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.